This is a quick overview of graphing of parabolas using the basic approach, which is generally introduced when parabolas are first encountered. And we commonly see equations of parabolas written in one of two formats. So when we write it as a function, we often will see the y isolated and then the quadratic expression having the coefficients a, b, and c on the terms of the quadratic expression. We will sometimes then package it up into vertex form, which has the coefficient a factored out, and then using complete the square, representing this is x minus h, and then plus k. And sometimes this plus k is subtracted off from both the left and the right, and then you end up with this expression, y minus k is equal to a times parentheses x minus h whole thing squared. And the vertex then has the coordinates h comma k. We can also write this parabola if it has a sideways format, and that is going to occur when you have your x isolated, but it having a second degree equation or second degree portion which uses y. And similarly, we can write this in vertex format as well. And so when you graph a parabola, you could just plot it point by point, but one common method is to use the vertex method because the vertex essentially places that parabola. And so once you know the direction of opening using the sign of the a coefficient, then finding the vertex will essentially tell you where the parabola is, and the last thing you need to do then is just to find out how wide it is. So let's take a look at this example. We've got the equation x is equal to negative y squared minus 2y plus 3. And the first question that's asked is which way does it face? And because the x is isolated and is first degree, but the y is quadratic, we are assuming that it's going to be a horizontal or a sideways facing parabola. And when we make the decision which way it faces, we're going to look at the coefficient on the second degree term. And because this is negative, then we're going to make the assumption that it faces towards the left. Next, we're going to find the vertex. And you may be familiar with the vertex formula for functions, again, where the y is isolated. And if we are trying to find the x-coordinate, which is h, that's given to be negative b divided by 2a, where b and a are coefficients. When we have a horizontal parabola, we're going to do something similar. Again, a and b will be coefficients on the second degree and first degree terms. But this time we're finding not the value of h, which is the x-coordinate of the vertex, but we're trying to find y. So our y value is going to be negative b divided by 2a, and that's going to be a negative 2, divided by 2 times negative 1 is the coefficient of the y squared. And so there's a lot of negative signs, but it does eventually come out to be negative, and then 2 divided by 2 gives us 1. And then to find our, so this is our k value, which is the y value. And then for h, our x value of our vertex, we want to use the formula. This is going to be the evaluated expression. So this will be equal to a negative y squared, which is a negative 1 parentheses squared, minus 2 times a negative 1, and then plus 3. So we end up with negative 1, positive 2, and then plus 3. So that gives us 4. So the coordinates of our vertex, our h is 4, and our k is negative 1. So if we plot this on the grid, we've got the point 4, negative 1 is down here. And as we mentioned, it's going to be a left-facing parabola, so I'm just going to kind of draw that inclination towards the left. But I want to get a few points to put on the graph so that we can get the actual width of this parabola. And we could let y equal 0. So at y is equal to 0, then we get just x is equal to positive 3. So that will be that intercept. But I think it's maybe beneficial to get some points that are further from the vertex. So if I were to look for the y-intercepts, letting x equal 0, then what I would get is a negative y squared. And so I just want to divide everything by negative 1. And letting 0 be divided by negative 1, we can just turn around the signs on those coefficients. So I end up with y squared plus 2y minus 3 is equal to 0. And when I factor that out, I get the opposite signs, factors of 3. So I'm going to have a positive 3 and negative 1. And so the y values are y is equal to negative 3 and positive 1. So on my graph at 0, 1, I have a point, and at 0, negative 3, I have a point, and then I can draw this parabola.